Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0420, indicates an issue with the catalyst system efficiency in the Honda Accord models from 2012 to 2017. Specifically, this DTC is triggered when the performance of the warm-up three-way catalytic converter, WUTWC, is below the expected threshold. The WUTWC plays a crucial role in converting harmful gases in the exhaust, such as hydrocarbons and carbon monoxide, into less harmful emissions, including water vapor and carbon dioxide. The Powertrain Control Module, PCM, monitors this process by adjusting the air-fuel mixture and observing the secondary heated oxygen sensor, secondary HO2S. If this sensor indicates that the performance is deteriorating over time, the PCM records the fault and sets this DTC. The monitoring process occurs once per driving cycle and is sensitive to various operating conditions, such as engine temperature and vehicle speed. The sixth troubleshooting step involves setting the cruise control at 55 miles per hour and maintaining that speed for at least 68 seconds. This controlled speed allows for consistent data collection and is particularly useful for assessing long-term performance of the WUTWC. If you've recently disconnected the vehicle's battery, this time needs to be extended to 4 minutes or longer. This extended drive helps wake up the system after a reset, ensuring that it's able to correctly monitor all relevant parameters. Always remember to drive under conditions that adhere to traffic regulations and environmental safety for accurate results. This careful approach maximizes the likelihood of diagnosing the root cause of the DTC P0420. After completing all troubleshooting steps related to DTC P0420, it's essential to perform a final repair verification. Start by clearing the DTC using a scan tool to reset the vehicle's systems. Once cleared, conduct a test drive under various conditions similar to those experienced in the earlier diagnostic steps. Pay close attention to any reoccurrence of the DTC and monitor the vehicle's performance during different driving scenarios. This evaluation will confirm whether the issue has been resolved or if further investigation is necessary. Successfully clearing the DTC without it returning indicates that the problem has likely been addressed effectively. Preventive maintenance is vital in avoiding future occurrences of DTC P0420. Regular inspections of the exhaust system can help identify any physical obstructions or issues related to the catalytic converter or sensors before they escalate into more severe problems. Additionally, monitoring the quality of fuel used in the vehicle ensures that impurities do not affect the catalyst's performance. Ensuring that all sensor connections are tight and free from corrosion can prevent electrical noise that may interfere with the readings. By instituting these preventive measures, vehicle owners can help maintain the integrity of their Honda Accord's emission systems, thereby reducing the likelihood of facing DTC P0420 again. In conclusion, DTC P0420 signifies a critical issue with the catalytic converter's efficiency in Honda Accords from 2012 to 2017. Thorough diagnosis and careful troubleshooting steps are essential to accurately pinpointing the underlying causes of this DTC. Components like the WTWC and secondary HO2S play pivotal roles in overall emissions control, and their performance directly impacts not only emissions, but also fuel efficiency and engine performance. By recognizing symptoms and taking timely corrective actions, vehicle owners can mitigate the effect of this error. Lastly, regular maintenance practices should be prioritized to ensure the ongoing health and operational efficiency of these vital systems, thus keeping vehicles compliant with environmental standards. The ER P0420 involves specific components critical for emission control, including the warm-up three-way catalytic converter, WTWC, and the secondary heated oxygen sensor, secondary HO2S. The WTWC is located in the exhaust system, typically near the engine manifold. Its primary duty is to convert harmful exhaust emissions into less harmful gases during the warm-up phase of the engine. The secondary HO2S, also located in the exhaust system downstream of the catalytic converter, provides feedback to the PCM about the converter's performance. When the secondary HO2S detects that the catalyst isn't performing efficiently, it affects not only the vehicle's emissions, but can also generate this DTC, leading to the illumination of the malfunction indicator lamp, MIL. The PCM relies on these components to manage and maintain optimal air-fuel ratios for emissions control. There are several potential causes for the DTC P0420. One common cause is the degradation of the warm-up three-way catalytic converter, WOUTWC. Over time, the catalyst inside can wear out and become less effective, leading to poor conversion of exhaust gases. Another possible culprit is electrical noise in the line, associated with the secondary heated oxygen sensor, secondary HO2S. This interference can mislead the PCM regarding the sensor's output. Additionally, a loose connection at the secondary HO2S connector can also disrupt communication between the sensor and the PCM. Lastly, modifications to the exhaust system that do not incorporate genuine Honda parts can affect the catalyst's performance, triggering this DTC. Therefore, a thorough diagnosis is critical to pinpoint the precise cause. The symptoms associated with DTC P0420 can significantly impact the driving experience. The most obvious symptom is the illumination of the malfunction indicator lamp, MIL, on the dashboard, which warns the driver of an emissions-related issue. In many cases, drivers may also notice a decrease in fuel efficiency, as the PCM struggles to manage an optimal air-fuel ratio. Fuel consumption can rise. Additionally, poor engine performance can manifest as sluggish acceleration, misfires, or rough idling. These symptoms can create a frustrating experience, leading drivers to seek diagnosis and repair. Understanding these symptoms is crucial for identifying and addressing the underlying issue promptly. The first step in troubleshooting DTC P0420 involves starting the engine and holding the engine speed at 3,000 RPM without any load. This means that if you have a continuously variable transmission, CVT, the gear should be in park or neutral. For manual transmissions, it should be in neutral as well. It is crucial to maintain this RPM until the radiator fan activates, indicating that the engine and its components are getting to the necessary operating temperature. Once the fan comes on, allow the engine to return to idle. This initial step sets the stage for further diagnosis by ensuring that the engine and the catalytic converter heat up adequately, as their performance is heavily temperature dependent. In the second troubleshooting step, you will need to drive the vehicle at a speed between 45 to 75 miles per hour for at least 5 minutes. This is crucial for ensuring that the warm-up three-way catalytic converter, WUTWC, reaches optimal operating temperature, which is essential for accurate performance monitoring. During this period, the engine must be under load, as this promotes the necessary exhaust flow and heat generation within the WUTWC. It is important to remain within this speed range, as driving too slow would not allow the catalyst enough heat to function properly, while going too fast could lead to other complications. proper thermal conditions are vital for a successful diagnostic outcome. For the third step in troubleshooting DTC P0420, you need to drive at a steady speed between 55 to 75 miles per hour for at least 10 seconds. This phase is crucial for allowing the Powertrain Control Module, PCM, to gather consistent data from the secondary heated oxygen sensor, HO2S, about the catalytic converter's efficiency. Maintaining a steady speed ensures that the exhaust gases flowing through the WUTWC remain consistent, allowing the PCM to assess how well it is processing those gases. By monitoring this data, the PCM can identify whether the catalyst is functioning within acceptable parameters. Failing to keep a consistent speed may lead to inaccurate readings, thus complicating the diagnosis. The fourth step involves decelerating the vehicle with the throttle valve fully closed. This means that you should remove your foot from the accelerator while allowing the vehicle to slow down naturally. During this deceleration, it's crucial to observe the vehicle's behavior and to keep an eye on the PCM data. This step is vital because closed throttle deceleration provides a unique opportunity for the PCM to assess how the engine and catalytic converter respond under different conditions. Tracking this data will help in determining if there are inconsistencies in how the WUTWC handles exhaust gases. Any abnormalities noted during this phase will be critical in confirming the presence of the fault. In the fifth step, you will need to repeat the previous driving pattern outlined in steps 3 and 4, a total of 5 times. This repetition is essential for ensuring that you gather enough data for a reliable assessment of the warm-up 3-way catalytic converter's performance. You should meticulously monitor the vehicle's speed and throttle position while ensuring that both the secondary HO2S and the PCM readings remain consistent across all test runs. It's this consistency that helps confirm whether the catalyst is truly underperforming or if other extraneous factors contributed to triggering the DTC. Using this repeat testing strategy can reveal intermittent issues that may not be apparent in a single cycle. Please like and subscribe to the channel. See you next time.